And so I have a few to go over. And then I know that a couple of you had some questions about some too. So I'm going to go over these first. The first one is 5 plus 3/4 over 4 minus 2/5. This is a complex fraction. This is one like we had last time. And we had some people that had some trouble with this, several. So what you want to do is look for denominators. There's a 4 and there's a 5. So you need a common denominator for 4 and 5, something that 4 and 5 will go into. And you want to think larger. So 4 won't go into 5, but 4 times 5 is 20. So 20 would be a good number to use. Then each part of your fraction, you multiply by that 20. So it's 5 times 20 plus 3/4 times 20 over 4 times 20 minus 2/5 times 20. Okay? All right. Sometimes people forget to multiply by those whole numbers. So we'll have 100. The 4 will cancel into 25 times. So you'll have 15 because 3 times 5 is 15. 4 times 20 is 80 minus 5 will go into 24 times. 4 times 2 is 8. So it looks like that we have 115 over 72. So that would be your answer. And the 2 or 3 people that missed that, a couple didn't multiply their whole number by the 20, and then the others just made an arithmetic mistake. It wasn't anything major. It was little, but it still won't count it right for you if you have anything wrong. Do we have any questions about that problem? You might recognize it as one that you had. All right, let's talk about another one that's similar to that. It's 2 plus 2/3 over 3 minus 4/5. This was on several people. The same problem was on several people's list as missing it. This time I need a common denominator for 3 and 5 because 3's in the denominator and 5's in the denominator. So that would be 15. 3 times 5 is 15. So 2 times 15 plus 2/3 times 15 over 3 times 15 minus 4/5 times 15. Some of you may recognize this problem as one that you had. 3 will go into 15 5 times. So 2 times 15 over here is 30, plus 2 times 5 over here is 10. 3 times 15 is 45, minus 4 times 3 is 12. So it looks like I have 30 plus 10, which is 40. And 45 minus 12 is 33, if I'm not mistaken. Watch me tonight. See if I make mistakes, because I'm awfully tired from moving all those boxes today. So I'll probably make some mistakes tonight. So please catch them for me before it confuses someone. Any question? All right. Let's go to one of those that I think some people had trouble with, the fractions. We had an f of x is 3 over 1 minus 2x, and a g of x equals 1 over x. And this is one of those composition ones. You had to do f composed with g of x. Window, now I'm wondering if she wondering where I gone and where I've been. I lost a number in my phone. I don't think I've heard that before.
That was my friend.
She want the rent.
Okay, this is f composed with g of x, and I don't know what exactly happened, but they didn't even get anywhere close to the right answer. Remember that g is mentioned last, so you're going to pick up this g function that's right here, and you're picking up the whole rule, and you're going to take it over here, and you're going to put it in for x.
These problems got me so messed up. I did like 4 different attempts. I'm so happy you're going over these.
Yeah, me too.
I probably overthought it. I'm probably going to be mad when you're done.
Oh, it's just practice. You just got to practice it.
I probably didn't cancel it right because I literally wasn't even close. Like when it showed the answer, I was like about to cry. I was like, oh my gosh.
There's a lot of people that were like that, probably in the same boat. Some people just skipped it. So let's figure out how to do it. We're going to pick this whole 1 over x up, take this x out, and put that in its place. So now this problem is going to read 3 in the top, 1 minus 2 is going to stay right there. And where I took that x out, I'm going to put 1 over x. That's because I'm putting the g in the f. Okay? Now then, I get 3 over 1 minus, I could multiply this out, 2 over x if I want to. I've still got to get rid of that fraction no matter what I do. I could have done it in that step before. This x is my problem, so my common denominator is x. I'm going to multiply everything by x. So I say 3 times x, 1 times x, minus 2 over x times x. Now I cancel, and I have 3x over 1x is x minus 2. So that's my f composed with g.
I see where I messed up.
Good. Where did you
I
mess?
was close though.
Where did you
I
mess
keep
up?
forgetting to multiply the 1 also with the
Oh.
common denominator.
Yeah.
That's where I messed up.
Yeah. You have to do everything. Now let's talk about domain, because y'all don't like these domains. I know you don't. You're not the only ones that don't like it. But the domain for this, let's just take care of this one first in your answer one. That can't be a 0 in the bottom. So I say that x minus 2 cannot be equal to 0. Adding 2 gives me x cannot equal to 2. That's my 1. But don't forget, in these compositions, there's a hidden one. Which one of these functions do I call the hidden one?
F. Sorry, never mind.
The one that you put inside the other, because it becomes hidden in there when you put it in there. So this one right here is your hidden one for this one. It's also the one that is mentioned last. It's the same one over there. So is there a number I can't use for this one? Because it's inside there, and I have to consider that one as well. Is there a number I can't use in the bottom of that one?
0.
X cannot be equal to 0. So there's 2 places that it can't be. It can't be 0 and it can't be 2. So what I want to do is, my domain on these, I believe we're in interval notation. So I go from negative infinity up to 0 because 0 comes before 2. Use a parentheses to skip that 0. Put a union symbol, then put the 0 again. That's how you're skipping it. Comma up to 2. Close the parentheses at 2. Union, parentheses 2. That parentheses is how you're skipping that 2. And what this says is the domain goes from negative infinity to 0, skips the 0, goes to 2, skips the 2. It's not one of the points you can use, and then goes on its merry way to infinity.
Can you repeat the domain, what you just said, one more time?
What I just said, or how I got it?
Not how you got it.
But what I said.
Well, yeah, what you said.
All right, so the domain would be, and let me draw you a picture of what it looks like on a number line. It would be all of these numbers from negative infinity up to right close to where 0 is, just as close to 0 as you can possibly get. And then it's going to skip across 0, because you can't have a 0 from up here, from the hidden one. Then your set's going to continue to go between 0 and 2, but it's got to skip across that 2, and then it'll continue on until positive infinity. So that's what this says. Negative infinity to 0, skip the 0, go to 2, skip the 2, go to positive infinity. We're skipping the 2 because in the answer part, you can't have a 2 in that x or it will make the denominator 0. In the hidden one, you can't put a 0 in that x or it'll make the denominator 0. Got it?
Yep, that's where you're drawing the 0 for the first and second pair.
Mm-hmm. All right, let's go the other way. Because this problem was a problem the other way as well. F of x is 3 over 1 minus 2x was the f function. G of x was 1 over x. And this time we're going to go g composed with f of x. Okay? So this time we're going to pick up f. F is mentioned the last there. So we're going to pick up that f. So it's not just part of it, it's the whole thing. The whole thing right there. You're going to pick it up and you're going to bring it over here and you're going to put it in for x. So that 1 is going to stay up there on top. The 3 over 1 minus 2x is going to go in there where that x is. That's going to be taken out. You're going to put in 3 over 1 minus 2x. So the 1 that's there is going to stay. That's that 1 that was up there. Now we have 3 over 1 minus 2x in the bottom. That's the one we're putting in there. That's the f that we're putting inside the g. Now, we have this denominator, 1 minus 2x. So my common denominator is 1 minus 2x. So I'm going to multiply the top by 1 minus 2x and the bottom. And when I have a group in a fraction, I like to put a parenthesis around them that reminds me that it's a group. So I have to multiply that one by 1 minus 2x. It's a little group I'm multiplying. It's a binomial. Now in the top, I can distribute this 1 times 1 minus 2x, but it's not going to change it because it's 1. If it were a 2 or a 3 or a negative, it would. But nothing is going to change that top one, so it's going to be 1 minus 2x. In the bottom, you can see that the 1 minus 2x's are going to cancel because 1's in the top, 1's in the bottom. And I can put a 1 down there if that helps you feel better. So 3 times 1, because that would cancel 1 time, is 3. And look, I don't have any variables in the bottom this time. So I might think that my domain would be negative infinity to positive infinity.
I didn't know that we could multiply the 1 minus 2x. I was trying to separate it. I didn't know.
Oh,
Yeah, conceptually, I don't know how a variable in the denominator can be common.
oh, okay. Well, it can. You could have almost anything in a denominator, and all you have to do is just multiply by whatever that is in the denominator. This is a little group, and there's one little group, and think of it as just having 2 children in it. They're not twins because they're not alike, but 2 children in it. They're just 2 children together in that little parentheses. It makes a little group. So anything that's above or below a fraction bar that looks like this, usually they're binomials, sometimes they're trinomials, will make a little group. It forms a group. So that's why I like to put parentheses around them, because it reminds me that they go together. And if you put a fraction similar to this in your y equals to graph things, then you'll see a little box that will open up down there, or you'll have to put parentheses around the bottom for the denominator because the calculator won't know it's a group unless you put parentheses around it. So keep that in mind if you're graphing one that looks like that. Okay, any more questions about how I got 1 minus 2x is my common denominator? It's the only denominator I had. Didn't have a denominator in the top. I just had a 1. Okay, so it looks like it's negative infinity to positive infinity. But remember, I've got a hidden function here. In my hidden function up here, I had 1 minus 2x. So I need to set that 1 minus 2x that's in that bottom there not equal to 0 and see what it gives me. So negative 2x, if I subtracted 1 from both sides, we get negative 2x cannot equal negative 1. Divide out the negative 2, cancel out my negatives, and I would get x cannot equal to 1/2. So there really is something that it can't be. It can't be 1/2. So the domain's going to go from negative infinity to 1/2, union 1/2 to positive infinity. Skipping the 1/2, but it's not like the other one that had 2 places to skip. This one just has 1 place to skip, and it's not from the answer, it's from the hidden function. Got it? Maybe?
What was the last part that you just said?
I said that this place it's skipping is not from the answer. It's from the hidden function.
Okay,
Does that make sense?
I think so.
Yeah, I don't have a variable down here in this answer. I only have a 3. I have a variable in the bottom at all.
Doesn't matter what side you put first in the connection, that matters because that's the first part of the function. Is that right? Like if I put my answer in and I put the infinity 1/2 second, and then I put the 1/2 infinity.
If you turn this around, if you
Wait.
turn it around, it won't work. You've got to
Yeah. If I had it switched around, can I leave it connected right here? That'll make the answer wrong.
Right.
Okay,
You have to
okay.
go left to right. If you don't go left to right, they won't count it. Okay. Any questions? All right. Now, a couple of people said they had a question about something. Did you bring it with you? Did you have one from the homework that you had trouble?
Oh, you nailed it. That was the last one for the regular algebra.
Okay.
I had a problem with number 4 on the traditional non-support.
Okay.
It was f of x. Yeah, f of x equals x plus 2. And g of x was x minus 12. And I got confused. I don't remember if it was, I crossed it out. I don't remember if it was f of g or g of f.
Okay.
But I got one part of it wrong. I think it was the f of g part I got wrong.
Okay. Let's try f of g.
And I was really frustrated.
Well,
I
don't
guess
get
the answer
frustrated.
was
You need to text me if you get frustrated so that.
yeah, the answer was like x squared, but I got x minus 10. So I was confused.
Okay.
That one made me really mad.
Let's look at this. This is the hidden one right here. The G is the one you're going to pick up first. And you're going to put this X right here. Are you sure one of them wasn't squared?
The answer was x squared. I just don't understand how that was like the answer. So
No, there's a square term somewhere if it was X squared. If you put that X minus 12 right there where that X is and take that out, it's going to say X minus 12 plus 2, which is X minus 10, just like you said. There's no squared on it. Now, if one of them was squared, that would make sense. That it would be a problem. Hang on a second.
I don't know, because I could have sworn it said x squared on the form. Maybe it was wrong. I don't know. I don't. Is there an instance that these can ever be wrong?
Well, sure, because there are people that do them. So,
Okay, 'cause I
yes,
circled. Here, I'll show you. Like, I circled and I put x minus 10, but then I circled x with the question mark. Oh, I'm sorry. The answer was x apparently. But I wrote down the right answer, I thought. Did anyone else have an issue with this one?
I don't have that on my list of issues.
That's really weird. See, I don't know if you can see it, guys, but
I had one that a couple of people missed that was f of x equals x plus 20 and g of x equals x minus 20. And you had to find f composed with g of x. But this one is the one that will end up with x. So you'd have x, take that one out, and you would have x minus 20 plus 20. These two 20s would cancel, and you'd just have an x.
Yeah, that's what I got for that one.
Uh-huh. And when you do it the other way, the same thing happens. If you do g composed with f of x, then you're going to have x plus 20 minus 20, which is x. And when these two are both x, then those are what we're going to do today. Those are inverses of each other. When you compose one with the other, they're inverses. One will undo the other.
so if, like, let's say we solve a problem, we think it's right, should we just contact you next time?
Yes. Take a picture of it,
Okay.
send it to me, and say, what is wrong with this picture? And
I mean, I can send you a picture of my work too. I just don't want to be marked wrong when I could have sworn I had it right. That's why I was frustrated, because I'm like, it's x minus 10.
I did notice that some people put in, and it's my fault, some people put in x not equal to on a couple of the problems this time, and they just wanted the number. So before they had to have the x and is not equal to, and then this assignment, there were a couple of people that just put the whole thing in there and they counted it wrong because they just wanted the number. So,
Okay.
so be careful on it. If it doesn't work one way, then, and you know you're right, then try putting it, look at it and say, okay, do they want the number or do they want x equals the number, and see which way they want it, because sometimes they change their mind. And I think what happens is different people do the answers for different sections. So sometimes they want it in a different form.
Okay.
How can that be so inconsistent? I paid for a book and I'm giving you the right answer just because it's not in the form that you want it. That's asinine.
Yeah. Well, that's the advantage of having a teacher in the classroom, because when you have a test in the class and we have a blank there and I really want to adjust the number and you put x equals a number, then I go ahead and count it because I know what you're talking about. But I will tell you that on these tests and on the quizzes, I do go back through each problem. And if you have the right answer, no matter how you put it in there, if you've got the right answer, I'm going to go into the system and count that one right for you.
I understand that. I'm just saying, as a student and as somebody who's a little bit older and not afraid to speak up, that's some horseshit. I mean, if you got students across the board in every math class giving the right answers, but they're getting it wrong, and there's nobody corrected on the homework, it's not reflecting what the students are learning. It's reflecting poorly on us and you as a teacher. So I would think as a university, they need to call Blackboard and say, y'all need to put a scope of answers that are correct. Just because it's not the one that particular guy wanted, that doesn't make any sense.
Well,
I agree with that, because there's been so many times that I've done homework and I mean, everybody's done it where you go on there and you put the right answer in and they will count it wrong. And then you see at the top where to say the correct answer and you actually got it right.
Yeah.
And see what they don't realize also is that when that counts, that's your homework points. Like that counts against you if you got it right. That's what I don't get.
Yeah, I dealt with the same thing because I was like, I know I put that in there. Like, I'm going back scanning through little things, and it's right there. It's the right answer.
Well, the reason I'm frustrated is it trips me up. It makes me think I'm doing something opposite than what I've been taught. That's where the grit comes in. Is you end up confusing yourself, you know. And anyway, shut up.
You can solve that problem if you'll just contact me. I'll tell you if it's right or wrong. Okay. And we can send a note to the Blackboard people. If you all will find the ones that do that, I'll send a note to it's not really Blackboard, it's the My Labs people. Pearson Products is who it is. And I'll send them a note. We can do that. I've done that before. Sometimes it works, actually. Let's talk about
It does.
our lesson tonight. We are on section 9.2. And this one is a pretty cool section that we're going to do. We're going to try to get through these new problems. So take some notes, or if you have the notes from the content area and you've copied it off, I'm going to follow those notes pretty closely tonight. Okay, we're going to talk about the word solve. The word solve means the problem will be an equation, or it might be an inequality. Okay, it's not just an expression like we talked about last time we met. It's going to have an equal sign or one of those less than, greater thans, or what less than or equal to, greater than or equal to problems. But as some of you know, there are three options for equations. When you're solving an equation, you can get an answer. That's what everybody likes to do. You get one answer. And that's also called a solution. Sometimes they say answer and sometimes they say a solution. And it's going to be x equals something or a variable equals something. So just know that that's the one you like to do because that doesn't cause any trouble. Sometimes you get a problem that has no answer. And it's not a mistake. There just is no answer. And there's a symbol for no answer. It's a little circle with a line slashed through it. That means empty set. And we're going to run into those. You may not run into one tonight, but you will. So we'll have several of those before the end of class. And I want you to be aware that they're going to happen. And I'm going to give you an example of one. If you have 2 times 3x minus 4 equals 7 plus 6x, let's say, and you're trying to solve this, you multiply your 2, you're going to distribute it, and you get 6x minus 8 equals 7 plus 6x. And generally, we like to have our numbers on the left side and our numbers on the right side, our letters on the left side. Tonight's assignment, there's going to be some exceptions to that rule that'll make it easier, a step easier for you if you don't do that. But let's see what we get here on this one. When I subtract off the 6x from both sides, my x's just disappear. They go away. And I'm thinking, that's not a good thing. I don't have any more x's. It's not like this one where I have x equals some number. What happened to my x's? So what you have left is not a solved problem anymore. It is a statement. It's a statement that is either going to be true or false. Is a negative 8 equal to 7?
No.
Ew.
No. So if you have a false statement because your variables have subtracted out and you have a false statement left, then your answer is no solution, no answer, empty set, not going to happen, can't work, all of those things. The third option is that a problem can have infinitely many answers. All the numbers work. Every number you can think of works. That's called infinitely many solutions. Sometimes it'll be written negative infinity to positive infinity. Sometimes it'll be written all real numbers. Means everything that you could think of would work in that problem. And let's see what happens in a problem like that. Suppose I had 1 over 2x plus 2 equals 1/2 over x plus 1. Okay? Now, I can multiply both sides by this common denominator of x plus 1 times 2x plus 2. Notice those are groups. Or there's another way I can do these kinds of problems that some of you might remember from way ago in your lifetime that's called cross multiplying. If you have one thing on this side and one thing on this side, you can cross multiply across that equation. Does anybody remember that in your lifetime? Yes, those are called proportions. All of you nurses that are in the group, you'll be doing a lot of cross multiplication. That's the way they solve those problems all the time in nursing. So I'm going to show you how to do that. We could just find a common denominator and that would work. But if you cross multiply, you take this one times the top one. So it's going to be 1 times x plus 1 on this side.
Yeah, I remember that. Okay, yeah, I remember.
And on this side, you go the other way. Do you remember that? And it makes kind of a heart. 1/2 times 2x plus 2. I have a student trying to get in. Okay, now let's see. 1 times x plus 1 is just x plus 1. And 1/2 times 2x plus 2. 1/2 of 2 is 1. So that's just x plus 1. What do you see on both sides of that equation? Look at my x's. They disappeared like they did a while ago. So what I have left is a statement. The statement will either be true or false. If it's false, the answer's empty set. No answers possible. If it's true, then your answer is infinite solutions. That's what this author's saying right now.
Would that be written negative infinity, comma infinity?
Can be.
Okay.
You'll have to see, this is going to be a multiple choice question, and it will depend on which way he's choosing to write it. Okay. So there's 3 options if you have particularly an equation, and we're going to move into those possibilities of no solution and possibilities of all real numbers. Okay, that's so.
And you said those they use a lot in nursing?
Yes, those
Okay.
Cross multiplying problems, the ones where you have to cross the bottom times the top and then put the answer here, bottom times the top, put the answer here. Those are all, we use those all the time in nursing. So you'll learn to do those really well. You'll have hundreds of them to do. Beth uses that all the time, every day when she's working. All right, let's talk about solving some equations that have a radical in it. If you have a radical that's just like this, Most people call it a square root because that's what it is. It's a square root. And there's an index number right here that's understood to be 2. It's not written there. You just know it's 2. That's a square root. Okay? Square root problems, because they're kin to parabolas, will be half of a parabola, but it'll be on its side and it'll look like that. We'll do some square roots tonight. That's a new added to our collection of different kinds of graphs. Now, it could be that you have something bigger than a square root. You could have a cubed root, or a fourth root, or a fifth root. This would be a 3 that's right here. That's called a cubed root. And it's kin to our cubed that we have, except it's kind of laying on its side. It looks like that instead of up and down. And we have fourth roots and fifth roots and so on. But we're going to talk about how to solve these equations. They're going to start us off with equations before they start asking us to graph them. So we're going to solve this equation. And the thing that you have to be careful about square roots is that you have to check your answer, because in square roots, you can get a number for an answer that won't actually work in your problem, because under a square root, you have to keep that value positive or 0. In our course, we can't find the square root of something like -12 right now, because that's an imaginary number. So we have to watch out for negatives there. Now, later on, we'll work with those when we get into the imaginary system. But right now, you've got to make sure you don't have any negatives in your square root, or otherwise it is undefined under the real numbers. You have to move into imaginary numbers to get that. So we'll have to check our answer is what that means. So to undo a square, to undo something that's squared, what you have to do is square it. So when the index number and the outside exponent match, it cancels out the square root symbol. The same thing with cubed root. If you had the cube root of something and you cubed it, it's going to cancel each other out and make the symbol go away. So to solve these, what you want to do is, since this is a square root, you're going to square both sides. So the square root of 2x plus 1, quantity squared, is what I'm going to have there, equals 3 squared. If I square this side, I have to square the other side. Just like in this example, if I square that square root, it's going to take it off. So on this side, all I have is 2x plus 1. On this side, I have 3 squared, which is 3 times 3, which is 9. Now I have a nice little equation I can solve. 2x is 8, so x equals 4 when I divide both sides by 2. Then I just put my 4 in there. 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. So that one works. It's okay. If I'd gotten -9 under there, I would have said that root would not work. That answer does not work. But that one did work, so that's my answer. Any questions about square root equations?
Can you do another example, please?
I sure will. Let's do the square root of, let's see if I've got one off of our work that we can just do one that you're going to have to do anyway. Yep, here's one. This is going to be like your number 4 that you're going to have on your homework. This is 8x minus 5 equals 1. It's square root. because there's understood little 2 up there. I'm going to square both sides to solve it. When I square this side, I just get 8x minus 5. It eliminates the square root symbol. On this side, I get 1. 1 squared is 1 times 1, which is 1. Adding 5, I get 8x equals 6. Divide by 8, and x is equal to, let's reduce it. 2 will go into 6 3 times, 2 will go into 8 4 times. So my answer is going to be 3/4. If I put 3/4 back in there, I would have 8 times 3/4 minus 5. 4 will go into 8 2 times. 2 times 3 is 6. So I have 6 minus 5 under there. 6 minus 5 is 1. Square root of 1 is 1. So that checks. So this is a good answer. Got it? Let's do one with a cube. Let me pick one off of your assignment that has a cube. Number 6 has a cube. It has the cube root of x equals -4. And you see it has the little 3 marked up there in that little index. That's called an index. I-N-D-E-X. Index. So instead of squaring both sides, what would I do?
Cube it.
I would cube both sides. So I have the cubed root of x, and I'm going to cube it. -4 cubed. That's going to take that off, and I just have x. And -4 times -4 times -4 is -64. If I put this back in, the cubed root of -64 is -4. That is true. The cube root of -64 is -4. I thought you couldn't have a negative in there. How come I couldn't have a negative now? I just said a while ago I couldn't have a negative in there. Why do I have a negative now? What's the difference?
This is cubed.
It's cubed. You can't have a negative if it's squared, or any even power, actually. Very good, Brooke. You were paying attention. Okay. We'll do another one of those in a minute when we do the problems. Let's talk about inverses. Inverses are easy, easy, easy.
Wait, can you go back to that last question, please?
I sure can. It's just like magic.
Okay. So with a regular square root, you square it and it's fine. What makes it so different when you cube it that you have to cube the other side?
Well, we had to square the other side too. See? We squared the 1. It just happened to be the same. We squared the 3 up here, and it became 9.
Okay. Never mind.
That answer that?
Yep.
I think it was down here. You probably didn't realize I squared the 1.
Yeah, that's what I was looking at.
But 1 squared is 1, so we're good. All right, any other questions before we go to inverses? All right, we're going to stop before we jump into inverses, and we're going to take our poll. So let me get my poll up here. And we're going down to this question. I'm going to launch the poll and see if everybody will answer it. This is part of the way that we do our attendance, actually. So I see who all responds, and it counts it for you. You have 13 folks that have answered it. Okay, let me show you what the results are. Can you see those? Several of you are using the Zooms from our classes, and it takes me till the next day sometime to get those to come up. Several of you have not used any of the videos. That's okay. You don't have to. And Dr. Rathvin's videos is up. So some of you have used, 10% of you have used his videos. He is very good. He doesn't always teach the instruction the same way that I do. Like tonight, there's a little difference in how he's using his calculator than I do, but that's okay. That just gives you a different way to look to see how to do it. It works fine. That way gives you some new information there that you might not know, and it might be an easier way for you to do it. So keep in mind, it looks like that no one has used the videos from the book, and those are found under resources that are from the textbook, and not every section has them, but those are done really well. Those videos from the text are there in case you want to use that. Okay, thank you. That will count our attendance. The attendance is counted 3 times randomly, and then the poll counts as an attendance, so that if you're dropping off and back on and something has happened in the middle and were there for the first attendance but weren't there for the second one, sometimes it'll pick you up for the third one. And I don't get a report on that but about once a week to know who's dropped off, and sometimes I send notes to people and ask them if they were there or not. Okay, let's talk about inverses. Inverse functions are a way to undo a function. Okay, to find the inverse with points, swap. I like that word, swap. Swap the x and y values. That seems pretty easy. So if we had f of x equals the set of points 1, 2, 3, 5, -3, 7. Okay? It's real easy to find the inverse. And there's a notation for inverse. It's kind of funny. It looks like a little negative exponent. But it means the inverse of f, some function f. That's what that f to that -1 is. You'll hear me not hardly ever say f to the -1. I'll say f inverse, because that's what that means. F inverse of this will now be, I'm going to swap these two. So I'll have 2, 1. I'm going to swap these two, and I'll have 5, 3. And I'm going to swap these two, and I'll have 7, -3. So it's real easy. You just swap them. Okay. Now, if you have an equation instead of a set of ordered pairs, you still swap. But sometimes they're a little harder to see. So let's look at one. Let's suppose we start out with a function, f of x equals 2x plus 1. I really want to swap a y, not an f of x. So the first step that you want to do is change f of x to y. Remember, that means the same thing. So we can do it, and now we can swap. So y equals 2x plus 1 is what that really means. I've just changed my f of x to a y. Now then, I'm going to move the x over there and the y over there, Everything else stays the same. And I'm going to say that this starts my inverse. So if you'll just put I and V out there, it'll let me know that you don't think that this question is equal to this one. This is going to be the inverse of that equation. So the x is going to come over here. So that's going to say x equals, the 2 stays right where it is, and the y takes that place of that x plus 1. Okay? Now, in the first example that you're going to do this for, they'll let you just leave it like that. But later on, it will ask you to solve it for x and write it in the inverse notation. So we're going to go ahead and do that one at this point. So we're going to solve for y. This is where I was telling you, I usually don't ever leave my variable that I'm solving for on the right side. But when you're doing inverses, it's much better for you if you'll leave it right there where it is. So I'm going to subtract my 1 from both sides. So now I have x minus 1 on this side and 2y on the right side. I'm going to divide both sides by 2. So now I have y equals x minus 1 over 2. And then the last step is to use the special inverse notation. And that's that f to the negative 1. F inverse of x equals x minus 1 over 2. And that's the way you find an inverse if it's in equation form. Now,
Can we also write f of negative 1 of x? Like, can we write it the other way, or does it have to be like that on that side?
no, in fact, most people will bring it over here, and just because,
Okay. Because I was going to say, I kind of remember it being on the other side, but I wanted to clarify that.
just because they like it on the left side, and I do too. It's just
Okay.
easier to solve on the right side, but then you can just
Oh.
flip it. You can sure flip it. That's a great thing to do.
Okay.
Okay.
What does it say at the bottom of there? Because it's cut off
Bottom,
at the very bottom. Okay, equals, okay.
x minus 1 over 2. F to the negative 1 of x. Can you see it?
Yes, I can see it.
Okay.
Mm-hmm.
That means F inverse is x minus 1 over 2. And remember, that is in a parenthesis. That's up in the top, so there's really a little parentheses around it. It's a little group.
Will it count it as wrong if we don't put the parentheses?
You'll count it right as long as it's all in the top. Now, if you write it x over 2 and then put minus 1 after it, it's going to count it wrong. But as long as you put all of this in the top and write it as x minus 1 over 2, it'll count it right. The computer knows to make that a group when you put it in the top of a fraction. Okay? It's your calculator that doesn't know that. You're going to put that in your calculator unless you have one of those little things that Luke talked about the other day that you can use. You'll have to put parentheses around the x minus 1 to tell your calculator that that's a group. Otherwise, what it'll do is divide your 1 by 2 and not your x if you don't put it up there. Makes a funny looking picture sometimes. All right, let's talk about one-to-oneness. There is such a thing as a horizontal line test. We had a vertical line test. Remember that vertical line test? That was to test to see if you had a function. This one works like the vertical line test. Except that it's horizontal. But this one determines if a function is 1 to 1. And you'll see me abbreviate 1 to 1 like that. And a function needs to be 1 to 1 so that it has an inverse. A function needs to be 1 to 1 to have an inverse. Okay. So let's look at some. Suppose you had a nice little parabola. We like parabolas in this class. And I drew a horizontal line, not a vertical line. I know it's a function because if I drew a vertical line, it would only cross it in one. But what happens if I draw a horizontal line? That horizontal line will cross that graph in this one that I drew in 2 places. So this one is not 1 to 1. So you're going to say, are you telling me that parabolas don't have an inverse? Well, they don't in that form, but you're going to see what's going to happen is they're going to take their parabola and they're going to say, only consider the x's that are greater than or equal to 0. You'll see that happen. And what that's going to do is erase this side of it over here. So you only have half of a parabola. That's called restricting the domain. And that's the way they get away with doing parabolas and using them to find an inverse. They just cut off part of it, just like cutting off half of it. So just notice that we'll do that. We'll do one of those in a minute and you'll see what I'm talking about. If I had a cubic curve, is that cubic curve 1 to 1? Let's see. Let's draw some horizontal lines.
Yes.
I would say
Yes.
good job, guys. Let's try our new graph, our square root graph. What do you think about our square root graph?
Yes.
And we're going to add to our rational collection. We're going to add some rational pictures that look like this. That's when you have a squared term in the bottom instead of just an x in the bottom. Then your rational fraction just splits into 3 parts. It's kind of neat. What do you think about this one? Are we going to have these in this section because we're really wanting things that are 1 to 1? So what do you think?
No.
No. There's a couple of places I could draw in there. It would cross it in 2 places. This one's not 1 to 1. Okay. Let's do a square root. Let's do some square root graphs and see what they look like. And now we know, because I told you earlier, that square root graphs look like a parabola on its side, but it's only half of it. So grab your calculator and let's see if we can put in a square root graph and see what that thing looks like. Remember, there's a square root key. Do you remember where it's found? It's above the squared term. Puts a little square root key in there. If you want a cubed root, you'd have to go to math and see there's some cube roots there. But this is a square root. So let's put in x plus 2. And now my calculator is smart and it knows to put all of it underneath the radical. If you have an 83 or some 84s that are not pluses, you'll have to put a parentheses around it to let the calculator know that you want the x and the 2 to be inside there. Okay, so let's graph it and see what that thing looks like. It looks like half of a parabola, and it is 1 to 1. And look where it starts. If I do second in table, I can see that if I go beyond -2, I get errors over there Why do you think you get arrows before -2 there?
Because the graph starts at -2.
The graph starts at -2. Now look, remember way back when we were at the beginning of the course and we talked about inside what it would do? It would shift it. Outside shifts it up or down. Inside a quantity shifts it opposite of what you think it's going to do. See how that says +2 there? But what it's actually done is shifted over to -2. See that? So you can kind of sketch the graph of that square root graphs by just knowing a little bit about what the numbers do inside that square root. Now, is it 1-to-1? Is it?
Yes.
Yes. So if it's 1-to-1, then you can find the inverse. So let's go through the process of finding the inverse. And that's what the problems are going to say for you tonight. Check to see if they're 1-to-1, then find the inverse. I think all of them are 1-to-1. Remember the f of x, I'm going to change to a y. Leave the square root of x plus 2 right where it is. Now, I'm going to start my inverse step. My inverse step is where I swap the x and the y. Everything stays right where it is except that x and y. The x is going to come where the y is. The square root's going to stay where it is. The y is going to go in the place of x. And that +2 is going to stay inside that radical. Okay, now we'll use what we learned about how to solve square root equations, and we'll square both sides. So I'm going to square, I'm going to do it in this step so that we'll know what I did. I'm going to square both sides. So on this left side, I get x squared. On the right side, the square is going to make the radical symbol go away, and I just have y plus 2. Okay, I'm going to solve it for y. So I'm going to subtract the 2 from both sides, and I get x squared minus 2 equals to y. And now I'm going to use the special notation. Okay, so I'm going to say x squared minus 2 equals f inverse of x. And then a lot of people like for you to swap it so that that is on the other side. So now I have my answer. Any questions on that? Now, look at this answer. X squared minus 2. You see that? What does x squared minus 2 look like? I'm going to put it on this one. Bring it down and put this in here with
It's a
my
parabola.
a parabola.
Parabola.
Or is.
You know, a parabola.
Yeah, a parabola. X squared minus 2. Notice it's minus 2 instead of plus 2 because it's the inverse of that other one. Look how that does. See that? Can you see it? Now, what did I tell you about that one-to-oneness business? You remember that?
The inverse is not 1-to-1.
Yeah, I really don't need that to have that whole parabola. So I wonder how I could restrict it so that I just see this side of it. Anybody know? How can I restrict it? I only want to see the right side of it. Let me show you how you can do that in your calculator so you'll see what it looks like. I'm going to come down here in this, and this is one of those things that Dr. Rathbun does it a little differently. I can put my x squared minus 2 in a parentheses and square it. I don't want to square that. And delete that off. And then I want my 2. I don't want to square it again. X squared minus 2 in the parentheses. I guess I could have just done that without all that trouble. Put another parentheses in there. And there's a place that will let you restrict the area that you want. Put in the X. And you're looking for, you want that X to be greater than 0, greater than or equal to 0. So if you do second and math, there's a bunch of those things like that. Nope, sorry, that's the wrong one. There it is, second and math. And it's really the test thing. And you see those inequality symbols down there. That number 4 is greater than or equal to. So I can go down to 4 and enter. And it'll put a greater than or equal to 0 in there for me. And then when I graph that thing, it's got an error. Let me see where my error is. It's probably there on the end. Let's see. Yeah.
On that second line, yeah, your exponent.
Now let's see. Look, that is my graph for my square root and the inverse with the limited domain. That's the way you want them to look. They want to crisscross like that. If I did it kind of up here, it would look like this. And this is extra for your money for all of those 100-point people in this class. There's a line that goes through here that's y equals x that we're going to do in 3 chapters. And that line y equals x is the inverse line. And the original problem is reflected into that inverse line to get your inverse. Y equals x is your reflection across there.
Can you put your calculator back up? Because I was trying to do it, but can you hit the table? Not the table, but
Y equals?
the y equals, yes.
If you want,
and it's x squared minus 2.
Right. If you want to limit your domain, there are several ways to do it. But in this second one, I think the easiest way to do it is just to put your problem in a parentheses, and then behind that problem that you put in there, put your domain. That's what happens. See, this part right here is the domain. X is greater than or equal to 0. And that will only let you graph the part that has the x is greater than 0, greater than or equal to 0. You're going to have a problem like that, so just know that you can put it in your calculator the way you want it to by using those parentheses. If I were on the board, I'd just erase the side on the other, the side that I don't want. But since I'm not on the board, it's harder to erase here. That parabola that this would have been, you need to limit your domain because you don't want it to come over here because it's not 1-to-1. Okay, let's see how these problems look. Y'all need to take a breather. You okay? Let's see how these problems look that we're going to have. I'm going to do the college algebra ones first. They're not too bad. There's only a couple that has that restriction element in it. Let's see what they look like. You know, I'm going to push some of you a little bit further because some of you are really, really good. So every time I teach, I'm going to add a little bit of stuff that I know we're going to have in a further chapter that's pertaining to the kinds of things we've got, so that when you get to that other chapter, you're going to go, oh, I've seen that before. I know what she's talking about. So by the time we get there, and I've said it 3 or 4 times, maybe when you get to that material, you'll go, I know how to do that. Number 1, this is in the college algebra section. It's find the inverse. And in this one, they give you a -9, 2. And if you plotted these points, you would see that these points and their inverse points would reflect into the line y equals x. That's the problem right there. You want the inverse. Okay, now this should be the easy points for you. When you get this on the test, and there'll probably be one on the test like this, just remember this is an easy problem. So don't try to make it too hard. Just swap the x and y. So this will be 2, -9. This one will be -1, 1. This one's -4, -5. And this one's -5, 5. Now, I don't know if you have to put these in. Somebody that's done this, tell me, do you have to put the points in or do they give you multiple choice? Do y'all remember? I don't remember. I did the problem, but I don't remember if I had to put in the points or if it was a multiple choice. Either way, that's your inverse. So somebody can tell me if you want to look it up. Number 2 is find an equation of the inverse. And this is one you don't have to worry about doing so much to. It's already in the y form. Do you see that? It's not even written in function form. It's written in y form. So all you have to do is swap the x and y and leave it alone. Don't try to solve on this one. Just swap it. So these two things are going to swap. It's going to say y squared. Notice the 2 stays where it is. The y becomes x, and you have -8 over here. On this one, you don't have to worry about solving for y or doing anything else to it. You just swap it. Number 3, use the horizontal line test. And you're using the horizontal line test to determine if the function is 1-to-1. That's what you want to do. If it's 1-to-1. They will give you your function name as well when you're doing this. The first one they're going to give you is f of x equals 2.8 to the x. Now, we haven't done these yet. 2.8 to the x. Those are called exponential problems. Those are exponential functions. A great exponential function example that we're having right now is the coronavirus. It's an exponential function. If you take a segment of it, you can actually do the graph of it. So an exponential function looks like this, and they already have the picture for you. You don't have to worry about the picture. You just have to worry about drawing little horizontal lines in your mind to see if it's 1-to-1, and it's yes. It is 1-to-1. Then number 4 looks like this. It's an upside down parabola. So what would you say about that? They actually give you the equation. It's -x² plus 7.
No.
It's no, because if you drew a a horizontal line on it, you would get crossing in 2 places. So this is not. Now notice it's upside down because it's negative. Remember that? Squared because it's parabola. Plus 7 means this top point up here is going up to 7. And if I wanted to let it be 1-to-1, I would have to restrict it by saying let x be greater than or equal to 0. But didn't ask me to do all that yet. Number 5, they want to know if it's 1-to-1, and it looks like this. This is one of those rational functions, and they even give us the equation. It's 9 over x squared minus 5. So I can see that if I drew a horizontal line, the answer would be no, not 1-to-1. Number 6, we have y equals the cubed root of x plus 2. So it's on its side. It looks just like a cubic curve, but it's on its side. And if I drew horizontal lines, it would only cross it in one place, so it's yes. So there's 6 of those.
So you kind of can tell by looking at the equation, like if it's a parabola, like just by basic format, or if it's a rational, it's not going to be 1-to-1, correct?
Yeah, that's what my goal is to try to get everybody to look at an equation and go, oh, I know what that thing is. That's a parabola. It's upside down.
Usually if it's cubed, it will pass the horizontal line test, correct? Cubed equations.
The cubed equations will, because it doesn't matter which way you go. If they're cubic or cube rooted, they're going to both
Okay.
pass.
So anything cubed will. Okay.
Mhm. And these rational ones most often will never pass, I can't think of it.
But if it's positive, it's still not 1-to-1, correct? Let's
What's
say it was like x squared plus 5. It's still not
gonna be
1-to-1, correct?
because what happens is that curve on that too, that makes that thing curve like this. So it's never going to be 1-to-1 unless you.
No, I mean like number 5. Like if it was x squared plus 5, it's still not 1-to-1.
No,
correct?
it's not 1-to-1 because
of that. Okay.
it's a
Thank you.
it's a rational function.
Okay, yeah, because it's
Squared,
rational. Okay, perfect.
this squared part of this, this is just extra for your money. That's what makes that right there. And see, just that part alone would keep it from being 1-to-1. Okay. All right, let's go to 7. Number 7, they start having us find the inverse. Number 7, you have f of x is equal to x minus 5. And I know that that's a graph of a line that looks like that. You don't have to know that, but I like for you to kind of think about what that looks like. So the A part, is it 1-to-1? Yes or no?
Yes.
Yes.
I think all of these are going to be yes because they want you to find the inverse. Find inverse. So let's go through the process. F of x equals x minus 5. Change your f of x to y. Now, the next step right here is where you start your inverse. So I always like to put I and V out here because that helps me know that's when I'm starting my inverse process. That's when I swap. X equals y minus 5. Then I solve for y. So I add 5 to both sides, and I get x plus 5 equals y. Okay. Then I use that special notation, x plus 5 equals f inverse of x. And I'm going to move it to this side so that it'd be pretty. And that's a line. See, that's a line too. Actually, that line's up here. It looks just like that. Okay, any questions on that line that I did? Okay, let's do this. Number 8 is a line. F of x equals 4x minus 7. I'll just kind of show you where it goes. It's down here, 1, 2, 1, 2, 3, 4, 1. Kind of looks like that. Notice it's a line, so is it 1-to-1?
Yes.
Mm-hmm. Okay. And B, is it have an inverse? Let's see, f of x equals 4x minus 7. Y equals 4x minus 7. Then I'm going to do the inverse. Inverse is x equals 4y minus 7. Notice that all I do is pick up the x and put it where the y is. Pick up the y and put it where the x is. Now I solve for y, adding 7. I get x plus 7 equals 4y. Divide by 4. Change it to inverse. And you can put it over to the other side and make it pretty. Okay. Not too bad. You just got to remember the steps. And don't get this step and this step mixed up. This one is changing your f of x to y. The next step is actually swapping the x and the y's. Some students, if they miss these problems, it's because they get the step before the line and the step after the line mixed up.
So when do we know when we switch the y and the x? Because I'm a little confused. The last problem, we didn't switch the x and the y.
The last problem, 7?
Yeah, I think it was 7. We didn't switch the y and the x, right?
No, we did.
Oh, we did?
See, the first step is changing that f of x to y. The next step is to switch the y and the x. That's why the x's come here and the y's come over here.
Okay, so for both problems, we did switch. We just flipped them before we started the
only time we didn't switch in this homework was this number 2. And it didn't ask us, we switched the x and y, but it didn't ask us to solve anything. All it asked, it didn't even start with a function, see, it just started with a x squared y, and it asked us to swap. This is that number 2. It will be number 2 on your homework too. All you have to do on that one is just change places with x and y. You don't have to solve anything or put it in the function notation or anything like that. But once they start these problems, this number 6, I think it is, that starts, no, 7. 7's the one that starts. You have to determine if it's 1-to-1, then you have to find the inverse. So that goes through all those steps. Changing your f of x to y, swapping your x and y, solving for y, changing to f inverse. Okay? Let me write those steps down. F of x to y, then swap the x and the y, then solve for y, and then change y to f inverse. Those are the 4 steps. Does that help?
Yes.
Okay, let's do a harder one. Let's do number 9. Number 9 is going to be a problem that looks just like this for you. Notice this is a rational function, but this isn't like that other rational function we had. The one we had earlier was funny looking. Let's see if I can find it. I don't know which one it was. Hang on a second. Let me see if I can find it. It had it looked like, the other one we had looked like this. It had 2 branches up here, and it had a branch down here. Do you remember that one? That's a rational function too, but it has an x squared term in the bottom. And this one is not 1-to-1. So you can't find an inverse on it. But this one, see the difference? This one's a rational function too. This would have like 3 something here and x squared plus 2 in the bottom. But this one is a rational function, but this one is 1-to-1. See, I drew a horizontal lines across this. It would only cross in one place. So this is 1-to-1. The B part is this process. So let's see if we can do it. This is the inverse process. We have f of x equals 5 over x plus 2. So the first thing I do is change my f of x to y. Now then, this is where you want to split this from this one. This is where you start your inverse. This is where you swap the x and the y. So right there where it says y is going to say x now. And right there where it says x is going to say y. Now you have to solve for y. This is the inverse right here. It's just not in the inverse form. So I have to solve it for y. Now this one's a little trickier. I've got a denominator here. So I'm going to use my common denominator idea. I could have cross multiplied. Some of you want to try that. You can. And I'm going to multiply both sides by y plus 2. Over here, I have y plus 2 times x equals 5 now. And I'm going to do this a little differently than I did it on your, if you're looking at the notes. I'm going to shortcut it a little bit and divide out the x first. And I have y plus 2 equals 5 over x. Then I'm going to subtract the 2. So I have y equals 5 over x minus 2. Now that is my equation for my inverse. All I need to do is just put my special inverse notation where that y is, and I've got my inverse. Notice how these compare. This is minus 2 down here, and that's plus 2 up there.
Can we do another one? I kind of don't. Yeah, this one was a little bit over my head.
Okay, let's do another one. Let's do number 10. Number 10 is one of these. F of x equals x cubed minus 7. Remember, it's cubic. So this little curve, if you want to put it into your graph, it's going to kind of look like this. It's going to go down to 7. Cross at -7. But it's a cubic curve. And if I did those horizontal lines for the horizontal line test, it would only cross it in one place. So for the A part, is it 1-to-1? The answer is yes. So of course it's going to be, because they want you to find the inverse. So the inverse is what we're going to do next. And so I'm going to take my f of x equals x cubed minus 7. And I'm going to change that to y equals x cubed minus 7. Remember, you can do that. That's a good thing to do. That's the exact same equation. I haven't changed anything except f of x is y. Now then, this is where I do my inverse. This is where you swap. You don't swap to here. You're going to move the x over there, and the y is going to come over there. So this is going to say x equals y, the 3 stays there, y cubed minus 7. Are you good? Now you add 7 to both sides, and you get x plus 7 equals y cubed. Now, how do I get rid of a cubed? What's the opposite of a cubed? Anybody know?
Are we cubing the other side?
Or we got to cube root it. That's the opposite, or the undoing process of a cube. So what I'm going to do is do this little cubed root of x plus 7 here equals the cubed root of y cubed. Okay. Now, the cube root of x plus 7 we can't do anything with. We'll just have to leave it there. And over here, this is going to erase each other, and all I have is y. Now I put in my special notation. And if you want to, you can bring it over here. Notice the difference. This is cube rooted. That was cubed. This is plus 7. That's minus 7. Those undo each other. Okay, any questions?
What's the bottom? You just did F. Okay, yeah, that's what I needed to see.
-1. That's that little inverse notation. It's a little -1 up there. F to the -1 of x, which is F inverse of x. Okay, let's do a tricky one.
Actually, I have a question.
Yes.
How do you put the cubed square root in the calculator?
Oh, okay. Let's see if we can do it. Let's think. Where would that be? Let's go under math and look. Do you see under math? There is fraction, decimal, cube, cubed root. And then there's any number you want. You could put 4 or 5 or whatever number you want in there for the index and make it any radical. But let's graph this one and see what it looks like. So if I wanted to graph this answer, I would go y equals, I'm going to get rid of these others that are in here. Otherwise, I'll have a confused graph. And to get this cubed, I've just found it under math. Was that number 4? And see, it'll put that cubed in there for you. Can you see it? And then you just put in x plus 7. And you don't have to do anything else because you're not adding anything else. If you were going to add something after that, you'd have to hit this little arrow that goes to the right, and it will make it not have that arrow there. Otherwise, everything that you put after that will be under the radical. You have to tell it you want it to not put anything else under the radical. Then when you graph it, look, it's like a sideways cubic, because our cubic look like this, and this one's the same thing. It's just sideways. And let's put this original one in so we can see how they're crossing. Let's go down and put it in. It's x cubed, and that cubed is on that same key if you want to do that. That's number 3 if you want to do that instead of the caret, minus 7. And see, look, they cross right here. And there's a line that goes through here that's x equals y, and they're reflected into that. So it's like a mirror that's right here, and one is the reflection of the other. Isn't that cool? I think that's cool. Okay, let's do number 11. Number 11 is, and remember these problems are just like the ones you're going to have. Uh-oh, I've got a squared term here. So I can expect that you're going to limit my domain because that says 7x squared plus 3. So it's like a parabola that's skinny, that's moved up 3 is what that is. So what will happen then is there will be a comma and it will say, uh-oh, we can't have this parabola. We're going to have to cut it off. So my parabola would have looked like this. It's skinny because the 7 makes it skinny. And this would be 1, 2, 3. This would be 3. But what's happened when I put this part of it on there is it takes this part off on this side. So what I have left is just this part of the parabola to determine if it's 1 to 1. And remember, if you want to see the picture of it, you could put it in your calculator, but you'll have to remember to use parentheses around them. So I'd have to do parentheses 7x squared plus 3, close parentheses, open parentheses, x, and remember what I told you that greater than or equal to thing is? Where is it? Second math. It has those symbols on there. If you hit second in math, it's number 4. So now I have x is greater than or equal to 0. And now when I graph it, it'll only graph one side of my parabola. Isn't that cool? So what we've done is restrict the domain. So let's see what happens. Now, since I've restricted this domain for the A part, is it 1 to 1?
Yes.
Yes. Thank you, brother. So now since it's 1 to 1, I can find the inverse. So I'm going to say f of x equals 7x squared plus 3. I'm changing my f of x to y. Y equals 7x squared plus 3. I like to draw a line between my original problem and my new inverse because those are not equal. Now I'm going to swap my x's and y's. So it'll say x equals 7y squared plus 3. Now I'm going to solve for y. So I'm going to subtract 3 from both sides. And I'll have x minus 3 equals 7y squared. I need to get rid of the 7. So I'm going to divide out the 7. And I have an x minus 3 over 7 equals y squared. Now to undo that square on that y, I will take the square root of both sides. And the square root of y squared is just plain old y. And over here, I'll have the square root of x minus 3 over 7. And so the x square root of x minus 3 over 7 is f inverse. If you want to see it on your calculator, you can put it in there. I would put it in so you can see them reflect across that. I do second and square root. It's going to open that up. I'm going to put parentheses around my x minus 3 since it is a numerator. And I'm going to divide it by 7. And that's the end. All of that is under my square root. So I'm going to look at it and see what happens. And see, it's a reflection. This is the bottom that looks just like this one. And there's a line that goes across there, y equals x, and it's reflected into that line. If I square my screen, it would probably look a little better. Let me see if I can square my screen, because this is a rectangular screen, and you can see it a little better when I square the screen. That's what inverses do. They undo each other, and they're reflected into the line y equals x. Okay, any questions on that one? Okay, there's one more to do. This one's easy after all those hard ones, I think. Number 12 is f of x equals the square root of x minus 9. And that is a square root. And it's shifted to the right, opposite of what I think. So over here at positive 9, it looks like that. So the a part, is it 1 to 1? Yes, all of them are, because that's how they want you to find the inverse. So f of x equals the square root of x minus 9. So y equals the square root of x minus 9. Then I want to start my inverse. I'll swap my x and y. So I have x equals the square root of y minus 9. Now I'm going to square both sides. So that I can get rid of the radical over there. Now I have x squared equals y minus 9. Squaring that radical just takes it away. Now I add my 9 to both sides. And look, I have a parabola. I'm not surprised, because that's always what's going to be the inverse of that. So we have x squared plus 9 equals f inverse, or f inverse equals x squared plus 9. Now, because it is a parabola and it's going to have both of those little curves, then in fact it looks like this. It's plus 9, so it's up here at 9. Looks like that. I don't want all of it. I want to restrict it to x is greater than or equal to 0. And I think they ask for the restriction on it when they ask for it. You have to restrict it so it won't be, it's got to be 1 to 1. So
on our homework questions, are we going to have to graph this?
no.
Okay, I just wanted to make sure.
Now the graphs are just so that you can visually see if they're 1 to 1 or not. And see, this one won't be unless you make it x greater than or equal to 0. You've got to limit that domain. No, you don't have to graph them. I don't think you're ready to graph some of these yet. Maybe next week.
I would be extremely stressed if I had to graph it.
They're just visually an easier way. I think it's visually easier to see if they're 1 to 1 by doing the horizontal line test, by just looking at them. But you can graph them in your calculator too if you want to graph them and see a picture of them.
Yes, I agree.
But I think it's just easier if you see a picture of it. Okay, that is the college algebra section. We're going to spend the remainder of our time working on the support section, and they're going to seem easier than the ones we just did. Maybe. Do you have any questions?
Before we get started on that, I got a question.
Okay,
I just want to know if I can trouble somebody to show me on this calculator how you guys were putting in the x x is greater than or equal to. I don't know how to do that on the calculator. I must have missed that step.
Okay, let me show you. If you go on your calculator, go to your calculator. Let me clear all this stuff out of here. And you go to this second key, which is the blue one up there that's right next. See that second?
Mm-hmm.
If you
Yep.
hit second and you go down to the one that says test, do you see a word that says test? It's right above the math key. It's like down from
It's right above. It's right above the what?
the math key. It's right above the math.
Oh man.
You hit the back.
Okay, I see it.
Now hit it after you've hit second, and you'll see your
Mhm.
list of inequalities.
Okay,
You see it? Okay,
I
now
see it.
see if you can do it again. Second and quit again. You go second math. Second math, and that'll get your inequalities.
But it's still not showing me like, okay, the greater than or equal to. I don't see it. I see like,
Look at
I
mine.
see
Do you
square
see mine on
root.
the screen?
Uh-huh.
Does yours look like mine?
Uh-uh.
Okay, so let's try this again. What calculator have you got?
I got the TI 84 plus CE or something.
All right, it should do it. So
Okay.
did you hit your second key?
Second
And then hit
and
the
math.
says math. And
Oh, I must have hit something else. Okay. Yeah.
did you get it?
Okay. Yes, I got it.
Second and math.
I feel so slow.
Oh,
Okay,
no,
thank
that's
you.
okay. Probably somebody else needed that answer too. Okay, let's do some support ones.
So I definitely needed it too, so I appreciate it.
Don't ever hesitate to ask a question because somebody else out there needs that same question asked. I'd rather you ask it than get it off from here and go, oh man, I don't know how to do this. Okay, in this section, we are solving equations. So let's go back to our old rule of denominator. We have a denominator here, and those are z's. It's the only denominator I have, so my common denominator is z. So I'm going to multiply every part by z. So I have z times z plus 7 over z times z equals negative 8 times z. Don't forget to multiply that side over there by z. This is your first problem of the way it looks in your homework. Now I have z squared. These z's are going to cancel, which is what I wanted to do. I wanted to get rid of that denominator. And I have an 8z over here. Do you see you have a little 2 right there? See that 2? That makes this thing quadratic. When it's quadratic, you have to set it equal to 0. There's a 2 there. You've got to set your whole problem equal to 0. So I'm going to add this 8z to both sides so I can get a 0 over here. And I'm going to come put that 8z in the middle of z squared in the number so that what I have is a trinomial. Now I've set it equal to 0. Now then you have to factor. Now some of you may not remember how to factor, and it's okay. We'll do this as much as we can so to catch you up on factoring if you've forgotten how. Anytime you have a trinomial like this with 3 terms, it will factor into 2 binomials. Okay? Now, this one's not too bad because 7, the only way you can get it is 7 and 1. What you have trouble with sometimes is when it's 12, and there's multiple ways to get 12, or 6 even, where there's multiple ways to get 6. So this one shouldn't be too big a problem. For your binomials, you are factoring that first term and splitting it up so that when you would multiply it back, you would get z squared. So the only thing that you could do would be z and z. And then if you fooled it, you would get a z squared there. That's your first term. Okay, now then, let's go to our last position number. That's a 7. Okay. The only way you can factor 7 is 7 and 1. So this one's going to be pretty easy. Now I have to add factors of 7. That's what that that plus means right there. That means I have to add factors of 7 to get 8. Whatever is in the middle. Well, I know that 7 and 1 is 8. So all I have to do is add these together. And let's just check it. That would be z squared. Then outer would be 1z. Inner would be 7z. 1z and 7z would be my 8z in the middle. The outer and inner terms is what gives you your middle term. Then the last is 7 and 1. And of course, that's 7. So I know I've factored it correctly when I checked it. Now you set each factor, each group, equal to 0. So I'm going to set my z plus 7 equal to 0 and my z plus 1 equal to 0. And then I solve each one of them. Subtracting 7 from this side gives me -7 for one answer. Subtracting 1 gives me -1 for this answer. Now, I think on this one it says z equals, and it has a box. And you have to put these numbers in here. It doesn't matter what order you put them in, but you have to put a comma between them or it won't take it. So you have two numbers. Okay? Any questions on that? Now just make sure that your answers you get is not going to make this denominator 0. I don't think you're going to have any of those yet. You're not quite ready for that. But if either of these were 0 for my answer, I would have to throw it away. It's called an extraneous root because it makes your denominator 0. So you just throw that thing away. And we'd only have one answer in that case. If it had been a 0 and a -7, we'd just have one answer. But neither of these are 0, so I can use both answers in this problem. And what's going to happen is that's going to be a parabola. That's going to end up being a parabola that's going to cross in two places. It's going to cross at -7 and -1. That's what's going to happen to it. All right, let's try a second one. The second one is solved, and this is one that if we want to try to cross multiply, we can. See, you have a fraction and a fraction. See that? So the easiest way to do this is to cross multiply. You could multiply both sides by a common denominator of y plus 2 and y minus 5. But I think it might be easier to cross multiply. So I'm going to try that method. So we have 5 times y minus 5 equals, and this side is going to end up being 4 times y plus 2. See, you cross multiply there. Isn't that cool? Okay. So I do a distributive property here. We get 5y minus 25 equals 4y plus 8. And those of you that ever make a mistake at 25 or 8, if you'll just do this little process right here where you actually let's draw the lines, for some reason that keeps you from missing that second term. So if you find yourself missing these points right here, these numbers, then try just taking a second and drawing these out. For some reason, that tells your brain that you've got to multiply the 5 times the 5. So now I have y's on both sides and numbers on both sides. I'm going to get this y over here to this side by subtracting 4y. And I get 1y minus 25 equals 8. Adding 25 gives me y equals 33, I think. 33 is a good number. It won't make either of my denominators 0, so I'm good. Number 3. This is also a proportion. These are called proportions. If you have a fraction equal to a fraction. So you can either multiply both sides by 2y, or you can cross multiply. So if I cross multiply, I get 2 times y plus 3 equals 3y. 2y and 2 times 3 here. 2y plus 6 equals 3y. And notice my y's over here on this right side. I don't want to have to go to the trouble of getting it on the left side and putting a 0 over there. So I'm going to subtract the 2y from both sides. I think I've done enough algebra that I won't get mixed up doing it that way. So my answer is 6 equals y. And if I got a 0, it would be, I'd have to have an extraneous root. But I got a 6, so I can use a 6 there. Any questions on that one? Okay, it's past 8 o'clock. So those of you that want to drop off, you can. I only have 2 more problems. Yes, 3 more problems. 3 more problems. So I'm going to 3 or 4 more problems. So I'm going to do those for you really quickly so that you'll have an example of all the ones that you'll have tonight. And then I'll ask for some questions. It won't take long to do these. We have 8x minus 5 equals 1. I'm going to square both sides to get rid of that radical. So I have 8x minus 5 that I'm squaring. Over here I have 1 squared. So I have 8x minus 5 equals 1. Add 5. And I get 8x equals 6. Divide by 8. And I get x equals 3/4 because I'm going to divide this by 2. And I get 3/4. See, that one's not too bad. Number 5, I'm glad you stayed on board with me, those of you that did, because number 5 has a little bit of an exception to the rule that you might not know about unless you did it. You must isolate the square root. If you don't get it all by itself on one side first, then the problem becomes very difficult to solve. So first, subtract this 4 from both sides, and you get the square root of 5x equals 11. Now square both sides. When you square both sides now, you're going to have the square root of 5x squared equals 11 squared, which is 5x equals 121, and dividing out the 5 gives you 121/5. So be sure that you isolate that radical first. Okay, any questions on that? Okay, we're almost finished. Let's do 6.
Go back to that real quick. I need to copy that down. Give me 1 second.
Okay, sorry. This one needs a little star because you have to get rid of this 4 first. You have to isolate it. I'm sorry.
Okay. Yep.
Okay. All right. Let's try number 6. Number 6 says the cubed root of x equals -4. We did this one earlier. You have to raise each side to the 3rd power. And you get x equals -64. And number 7, you have the cubed root of x plus 5 equals 4. You want to cube root both sides. So you get x plus 5 equals 64. Subtract your 5, and you get x equals 59. Okay. Now that's all of the problems that you have to work tonight. Does anyone have a question? Let me see if anybody can remember if these folks were here that I didn't count here. Amanda Crutchfield. Was Amanda here?
I'm here.
Okay. And Sashini, she was here. Morgan Gay was here. Erica Gurley. Erica was here, wasn't she? Kelly Hill. Did anyone see Kelly Hill come in? How about Lori Lawrence?
Here.
Tamala Overton. Portia. Was Portia here tonight? Kiera Thomas. Donovan Tucker. Or Chantel Williams. Were any of those folks here? Okay.
I didn't know if you got me or not because I was having a couple internet problems at first.